this is the reaction between magnesium carbonate and the acid solution. So it started with P. P is used 0.05 mole of H2SO4. This is calculated from the MV over 1000. Okay, is from the question. So when the mole of H2SO4 is 0.05, so the mole of H plus must be double. So it's 0.10. And after that, the experiment is repeated using the same amount of carbonate, but now a different sample of acid. So magnesium carbonate is the same. Now, what is the acid that used to produce the Q? From this diagram, we know that the Q must be more dilute because the rate, as you can see, the rate of P actually is greater, right? So the Q is, the rate is lesser or smaller because of the slope is less steep. Okay, then we know that the Q must be a more dilute solution, but it must be the one that with larger mole of H plus, larger mole of H plus than P, because the amount of CO2 that produced is higher. So the moles of H plus must be larger. Okay, if you understand what I say, then the answer now, it just can be the D. So because if you calculate using the volume and the concentration, so you get the mole of H plus. Okay, so the mole of H plus is 0.2. And another solutions that can be compared is this one. Because B and D, after you calculate the numbers of H plus, they are the same, 0.2, 0.2. So why D is a better answer? Because since the numbers of moles of H plus, they are the same, 0.2, 0.2, but for the B, the volume is lesser than D, it's just 100 cm cube. So means the concentration of H plus here is more than D. So D, because the amount of H plus now in larger volume means the concentration of H plus is lesser and the rate is slower, right? Slower. So means it meets the requirement here, or the diagrams here. The Q must have a lower rate, okay, because the slope here, right? And the moles must larger than P, the moles of H plus, 0.2, right? So that's why D is the answer. Thank you.